Right now, as you're watching this, your computer is lying to you, not maliciously, calmly, politely. It tells you everything is running smoothly, that programs open instantly, that clicks cause actions, that nothing is stuck. But beneath that clean interface, there is traffic, crowded, negotiated, delayed, rerouted. Every keystroke you press joins a queue. Every app you open competes for attention. Every notification is asking the same quiet question: can I go now? Your operating system is not a static machine. It's a city with intersections, right-of-way rules, bottlenecks, shortcuts, and sometimes traffic jams you never see. Most people think slow computers are about weak hardware, more RAM, faster CPUs, newer chips. That's comforting, because hardware feels physical, fixable. The uncomfortable truth is this: even the fastest machines spend a shocking amount of time waiting for permission, waiting for access, waiting in line, and the system deciding who gets to move is invisible. This is the unseen traffic system inside your operating system. To understand why this invisible traffic system matters, you have to forget what your computer looks like. Forget the desktop, forget windows, icons, and progress bars. Those are billboards. The real action is underground. Modern operating systems were born from a problem that appeared decades ago, long before touchscreens and cloud sync. In the 1960s and 70s, computers were rare, expensive, and shared. One machine, many users. Everyone wanted it now. That forced engineers to invent rules. Who goes first? Who waits? Who gets cut off? Fairness, speed, and survival, all competing at the same time. That problem never went away. It just became quieter. Today, your laptop pretends it's only serving you. But in reality, it's juggling dozens, sometimes hundreds, of tiny requests every second. Your browser wants CPU time. Your music player wants memory. The system clock wants attention. Security services are watching everything. Background apps are whispering, just one more thing. None of these requests are dramatic on their own. They're small, measured in milliseconds, but they pile up. This is where the traffic system emerges. Every operating system, Windows, macOS, Linux, even your phone, runs on a scheduler. Think of it as a traffic officer who never sleeps. Its job is to decide which task gets access to the CPU, how long it gets to run, and when it's forcibly stopped to let someone else through. The uncomfortable part is that your programs are not actually running at the same time. Not really. They're taking turns so quickly it feels like simultaneity. Like a single-lane bridge with excellent choreography, and not all tasks are equal. Some processes are marked as urgent, some are best effort, some are politely told to wait in the background. The system makes these decisions constantly, often without telling you. Your video call might get priority. Your file download might slow down. Your antivirus might interrupt both. This hidden choreography is why your computer can feel fast and slow in the same moment. The mouse moves smoothly. The app freezes. The fan spins up like something is wrong, even though nothing looks wrong. The stakes have quietly risen. Back then, schedulers were about fairness. Today, they're about illusion. The illusion that everything is instant. The illusion that nothing is waiting. The illusion that you're in control. But every illusion needs a system to maintain it, and systems under pressure reveal their cracks. Here's where the calm story starts to strain. Because the traffic system inside your operating system doesn't just manage programs, it manages conflict. Every second, your CPU is flooded with requests that all believe they are important. The browser tab rendering an animation, the messaging app checking for new texts, the system service making sure nothing is on fire. None of them know about each other. They just raise their hands and ask to go. The scheduler decides, ruthlessly. It slices time into tiny pieces, often a few milliseconds long, and hands them out. Run, stop, switch, run, stop, switch, thousands of times per second. This constant context switching is expensive, not in money, in attention, in heat, in energy. And here's the irony. The more powerful your hardware becomes, the more traffic you invite. Fast CPUs encourage more background services, more animations, more smart features. Each one adds a new car to the road, individually harmless, collectively congested. This is why modern operating systems feel busy even when you're doing nothing. The machine is never idle. It's maintaining the illusion of readiness, preloading, predicting, indexing, syncing, watching. Now introduce priorities. Some tasks get VIP lanes. Audio playback, for example, is often protected from interruption because humans notice stutter instantly. Video decoding too. Miss a frame and your brain complains. Other tasks are sacrificed quietly. File copies slow down. Search indexing pauses. Battery optimization kicks in like a traffic cop waving cars aside. But priorities can lie. An app can ask for more importance than it deserves. A background process can misbehave. A poorly written driver can block the road entirely. And when that happens, everything behind it waits. Not because they're slow, but because they're polite. This is when users feel the system hang. The cursor still moves, the screen still updates, but clicks don't register. Audio glitches, fans roar, you're stuck at a red light with no visible cause. What's actually happening is congestion collapse. Too many tasks fighting for slices of time, too much switching, too many interruptions. The system spends more effort deciding who goes next than actually letting anyone go. The traffic system becomes the bottleneck, and the scariest part, from the outside it looks like nothing is wrong. This is the moment where the math turns against you, because once you see the traffic system clearly, you realize something unsettling. Your operating system is spending a measurable portion of its life not doing work, but deciding. Every context switch has overhead. Save the state, load the next one, flush caches, refill pipelines. It happens so fast you never notice, but it happens constantly. On a modern machine, this can mean millions of switches per second under heavy load. Now multiply that by power management, security checks, virtualization layers, and background telemetry. Each one adds checkpoints. Each one adds friction. The road doesn't just get crowded, it gets narrower. This is why a computer with absurdly powerful hardware can feel sluggish under the wrong conditions. Not because it lacks speed, but because it's trapped in negotiation, like a 6-lane highway, reduced to 1 lane by temporary rules that never quite get removed. Here's the quiet twist. Operating systems don't optimize for truth. They optimize for perception. Responsiveness matters more than throughput. A system that finishes tasks faster but freezes the mouse feels broken. A system that delays work but keeps the cursor moving feels alive. So schedulers are tuned to favor interaction, not completion. That's why opening an app feels instant, even if it's not ready. Why progress bars lie? Why not responding appears only after the system has tried very hard to hide the problem. And then there's fairness. In theory, schedulers aim to be fair. In practice, fairness is subjective. Is it fair to give equal time to a background backup in a video call? To your antivirus in your game? To the system and the user? Modern schedulers don't answer this philosophically. They answer it statistically, based on heuristics, based on past behavior, based on guesses, which means they can be wrong. A mispredicted workload, a spike of interrupts, a single thread holding a lock too long. Suddenly traffic backs up everywhere, latency explodes, and no amount of raw CPU power fixes it, because power doesn't dissolve coordination problems. This is the turning point most users never notice. Your computer didn't get slower. Your tasks didn't get heavier. The system simply reached a complexity threshold where managing traffic costs more than moving it. And once you cross that threshold, every added feature, every helpful service increases the risk of collapse. The illusion holds until it doesn't. So zoom out for a moment. The unseen traffic system inside your operating system isn't a flaw, it's a compromise. A delicate, constantly shifting truce between speed, fairness, and the feeling of control. Without it, modern computers wouldn't work at all. With it, they work just well enough that we stop asking questions. And that's the risk, because every year we ask our systems to do more in the background. More prediction, more syncing, more security, more smart behavior that runs whether we notice or not. Each addition is justified. Each one sounds small, but traffic systems don't fail because of one bad decision. They fail because of accumulation. The uncomfortable math never appears on the box. No spec sheet tells you how much time your CPU will spend waiting. No benchmark shows how often tasks are interrupted mid-thought. No upgrade warns you that coordination, not computation, is the real bottleneck. This is why two machines with identical hardware can feel completely different. Why a clean install feels snappy. Why older systems sometimes feel calmer, even if they're objectively slower. Fewer cars, fewer rules, less negotiation. It also explains why optimization advice is so strange. Close background apps, disable startup items, turn off visual effects, not because your computer is weak, but because you're thinning traffic. You're not speeding up the road. You're removing intersections. And the implications stretch beyond personal frustration. As operating systems become the foundation for cars, medical devices, financial systems, and AI workloads, invisible traffic decisions start carrying real-world consequences. Delays aren't just annoying, they're risky. A missed audio frame is fine. A missed control signal is not. Yet we keep adding complexity on top of complexity, trusting schedulers to sort it out quietly. Most of the time, they do. Until they don't. So the next time your computer hesitates for no obvious reason, don't blame the hardware. Don't blame yourself. Picture the city underneath, the queues, the rules, the silent negotiations happening faster than thought. And ask a simple, slightly unsettling question. If the most important system on your machine is the one you never see, how much trust should it really be allowed to earn? Done watching. If you like this video, hit subscribe for more cool stuff.